Today we're going to talk about solving systems algebraically, section 3.2. Again, this would have been something you would have done in Algebra 1. Just like last week, we talked about solving systems by graphing. So we can solve a system of equations by graphing. We can also do it algebraically by two methods called substitution and elimination. You guys remember here talking about substitution and elimination in Algebra 1? Yeah. So yeah, same thing here today, section 3.2. Wait, what? The first method we're going to talk about today is the substitution method. It's called the substitution method because the idea is to get a variable alone, or solve for a variable, and then I take what that equals. So for example here, y equals x plus 2, and I'm going to substitute all of that in place of y in my second equation. So when I substitute all of that, I now get 2x plus x plus 2 equals 17, and from there I solve for x. I get x equals 5. I take that, I substitute it back into an equation. I get y equals 7. My answer is again an ordered pair. We're talking about xy systems here, so all of our answers need to be as an ordered pair. And how can I check that it's true? I can plug it into each equation, and it should check out for both. Okay, so it's not about checking out for one. It has to satisfy both equations in order to be true. So for example here, I have 4x plus 3y equals 4. 2x minus y equals 7. Step 1 says to solve for one of the variables. As I look here, I have the top equation and the bottom equation. I need to solve for a variable in one of the equations. Which one looks like it's probably the easiest to solve for? The second equation and which variable? I would solve for y. Why would y look a lot easier in that second equation? Because it's singular. I don't have to divide by anything really technically here, right? So I need to solve for y. So the first thing I'm going to do is I'm going to subtract 2x to the other side. I get negative y equals negative 2x plus 7. But again, I need to get y alone, so I need to divide by what here? I need to divide by negative 1. Y equals 2x minus 7. Does everybody see that? I have y equals, I got y alone. Now, why do we want to get y alone? Because now I'm going to take what y equals, and I'm going to substitute it in place of y in my other equation. So I substitute that in, giving me 4x plus 3, parentheses, 2x minus 7 equals 4. I substitute it in because now I have singular x's. So I have single x there. Now I need to solve for x. So I would distribute 4x plus 6x minus 21 equals 4. Combine like terms, move the 21 to the other side. I get 10x equals 25, or x equals 2.5. Okay, so yeah, a lot of work. I got one of the variables now. Now that I have one of the variables, where do I need to take it? I need to plug it into. I need to plug that back in for x to solve for my other variable. So I'd say y equals 2 times 2.5 minus 7. Well, what's 2 times 2.5? 5. So I have y equals 5 minus 7. 5 minus 7 is? So I have y equals negative 2. Now I have my answer. However, I always need to write my answer as an ordered pair. So my answer here would be 2.5 comma negative 2 as an ordered pair. And there it is. Okay. And that's the method of substitution. Again, substitution is taking values and substituting it into other equations to solve. Let's try number 2. So here number 2, it says 2x minus 3y equals 6 and x plus y equals negative 12. Again, in order to do substitution, I need to substitute or solve for a variable and then substitute. So which variable or which equation do you want to work with? Joe Daniels, which one do you want to work with here? Bottom equation, and which variable do you want to solve for? Let's solve for y. Awesome. Does everybody see why the bottom equation is easier? Okay, there's no coefficients there really. So I'm going to subtract x. And I get y equals negative x minus 12. Is y equals now? Are we good? So I'm going to take what y equals, negative x minus 12, and I'm going to substitute it in place of y. So that gives me 2x minus 3, parentheses, negative x minus 12, equals 6. Does everybody see how I substituted in? Why do I have to substitute in with parentheses? Who knows why? What's the key about that? Why do I include parentheses around it? So I remember to do what? I have to remember to distribute, yeah. So I distribute that -3. So I get 2x plus 3x plus 36 equals 6. 2x plus 3x is 5x. So I get 5x equals -30. Does everybody see where I get the -30? Subtract 36 to the other side. So what's x going to equal then? X equals? -6. Now I got half my answer. What do I need to do now to find the other half? I take that and I plug it in. So that's going to give me y equals -6 minus 12. Two negatives give me a. So it's really y equals 6 minus 12. 6 minus 12 is? I can hear the enthusiasm, Joe, that away. So I get -6. What's my ordered pair now as an answer? -6, -6. And there's my answer as an ordered pair. Yeah, you bet. Again, the key is to solve for a variable and then substitute it in. That's why it's called the substitution method. All right?
That'd be so funny.
So let's try number 3 here. All right, so y equals 3x, 4x plus 3, y equals 26. What makes this one an easier problem? It already gives me y equals. So from here, I'm just going to take what y equals, and I substitute it and solve. Finish this one out on your own from here. So let's look through this here. We substitute it in. So you get 4x plus 3, parentheses 3x equals 26. I multiply, so I get 4x plus 9x equals 26. 13x equals 26. I get x equals 2. Now I have x equals 2. Which one do I want to plug it into, the top or bottom equation? I plug in the top. It's already solved for y. So I get y equals 3 times 2. Y equals 6. My ordered pair now is 2, 6. There's the answer. Okay. Try number 4 on your own. Same idea here. Take a couple seconds, try number 4 on your own. I would solve for y in either one of these. Okay. All right, let's look at number 4 here. Katie, which one did you solve for? Shh, gentlemen. You solve for the bottom one, and you solve for y? Right? So we subtracted 6x. Y equals -6x plus 200. Take what y equals. Substitute in place of y up here, right? So I get 2x plus -6x plus 200 equals 100, right? Combine like terms. -4x plus 200 equals 100. Subtract 200 over.
You gotta go a little slower. This is so high paced.
-4x equals -100. And what's x equal, Katie? X equals 25. So we have what x equals there?
Doesn't matter what equation you start with.
Nope.
Okay,
You can start with either one here.
Oh.
And then I take x equals 25 and I plug it in. So y equals -6 times 25 plus 200. So y equals -150 plus 200, which is y equals 50. Then my answer pair was what, Katie? 25, 50. Nice job. Nice job. Again, the key there is to substitute. Solve and substitute. All right, so that was substitution. The next thing we're talking about now is the elimination method. Okay, elimination method is probably the easiest of the three if they're set up to eliminate. The goal is if you know all three methods, you can use all three at any time, just based on what the problem's set up for. To use the elimination method, you want to have the variables or coefficients to be the same, but opposite signs here. So if you see that I have -2 and a positive 2y, the goal to eliminate is to set them up where they're opposite like that, because then I can eliminate and add down. 3x plus 5x is 8x. 7 plus 1 is 8. I get x equals 1. From there, I substitute that in place of x. I solve for y. And then I get my ordered pair 1, 2. So elimination is all about setting up the variables in order to eliminate a variable and then add down. So in order to eliminate them, they need to have the same number, different signs, and then we always add down. So for example number 5 here. I have 4x minus 2y equals 7 and x plus 2y equals 3. I want to eliminate a variable. Which one is set up to eliminate, the x or the y?
Why?
Who said it?
The y is set up to eliminate here. Why is the y set up to eliminate? Because they're both 2, and I have a positive and a negative.
Oh, then they cancel out.
So I'm going to add down by canceling them out. So 4x plus x gets me 7 plus 3 is. So I divide by 5. I get x equals 2.
This makes sense.
Now I take x equals 2 and I need to plug it into an equation. Which one would make more sense, the top or bottom one to plug it into? I would say the bottom one. It's positive, looks easier. So I plug it in. I get 2 plus 2y equals 3. Subtract 2. 2y equals 1. Divide by 2. Y equals 1/2. So I have 2 and 1/2. What's that as an ordered pair then? 2, 1/2. And there's my answer. That's elimination. Is elimination probably the easier of the 3? If the problems are set up to, yeah, it is. If they're not set up, then you have to look at what their steps are. If they're for graphing, graph it. If they're for substitution, substitution. But knowing all 3 will help you out. Like on a quiz or test, you'll probably want to know all 3 just because I'll set them up in different ways.
Yeah, what's the other one? That was just substitution.
Graphing. We did graphing last week. So 6. 3x minus 2y equals 14, and 2x plus 2y equals 6.
What is graph?
I want to use graph and look where they intersect. I want to set this up to eliminate. Are they already set up to eliminate, King?
What?
Are they set up to eliminate?
Yes.
Which ones are set up to eliminate?
1.
So I eliminate my y's. And I add down. 3x plus 2x is 5x. 14 plus 6 is, I have 5x equals 20, so x equals, I have x equals 4. Where am I going to plug that one into now? Top or bottom equation? I would go bottom.
Wait, what did I do?
So I have 2 times 4
What is it?
plus 2y equals 6.
What did I do?
So what's 2 times 4 then? 2 times 4 is 8.
What is this? What?
So you have 8 plus 2y equals 6. Subtract 8 to the other side. 2y equals negative 2. Y equals negative 1. My answer now as an ordered pair would be 4, negative 1. So there's your elimination. Take a couple seconds, try number 7 on your own. Same idea. Use the process of elimination to solve for x and y. Try these 2 on your own. Oh wait, this is the same one, wasn't it? Just kidding. Just kidding. The answer is 4, negative 1. That's right. We did this one.
What's the answer to the last one?
4, negative 1. It's the same one as number 7. I forgot. Those are the same problems. Alright, so let's look at number 8 now. I have 4x plus 9y equals 1 and 4x plus 6y equals negative 2. Remember, I need to set these up to eliminate. In order to set them up to eliminate, we have to have the same number, different signs. Are these set up to eliminate? No, but which ones look like they could be set up to eliminate? The x's. What am I going to have to do on one of those equations to make them? I'm going to have to multiply by a negative 1. If I multiply everything by a negative 1, I can change the signs and not change the equation. Which one would you want to multiply, top or bottom one, Katie? I'd multiply the bottom one. Why? Because there's already a negative, so I can make things positive. I don't know. Just makes things easier. So I'm going to multiply everything here by a negative 1. Doing so gives me now negative 4x minus 6y equals a positive 2. Now are my x's set up to eliminate? Yeah, now my x's can eliminate. 9y minus 6y is 3y. 1 plus 2 is 3. 3y equals 3, or y equals 1. Now I would take that back in. I would plug it into the top one, because the bottom one had negative. I always look to keep things positive. I don't know. So I have 4x plus 9 times 1 equals 1, which is 4x plus 9 equals 1. Subtract 9 to the other side. 4x equals negative 8. Divide by 4. X equals a negative 2. My answer now as an ordered pair would be negative 2, 1. Okay. Same thing on number 9. I'd want to do something here. Which one would you maybe want to change? Top or bottom one? I look at the top one. So yeah, I'd multiply the top one by negative 1 and then work it out. So on your own, try this one on your own here. Alright, so number 9 here. When I work it out, I'm going to get negative 5x minus y equals 0. And then 5x plus 2y equals 30. So I eliminate my x's and end up with y equals 30. So I have the first part now. I would take that and I plug it into the top equation. 5x plus 30 equals 0. Gives me 5x equals negative 30. X equals negative 6. My answer now is the ordered pair, negative 630. You have that, Katie?
Yeah.
That way. Last one, I believe. Number 10. I have 3x plus 7y equals 15, 5x plus 2y equals negative 4. I do want to solve this by elimination. Are any of them set up even remotely close to eliminate, though? No, so I need to do some multiplying here. Here's the question. Do we want to eliminate x's or y's? Doesn't matter. Let's eliminate y's, okay? So I want to look to eliminate y's. Well, what's a common multiple of 7 and 2?
14.
Okay, so I want to somehow get these to 14. So what am I going to multiply the first equation by?
2.
So I multiply the first equation by 2. And I get 6x plus 14y equals 30. What am I going to multiply the second equation by?
7.
Ooh, not just 7, but actually I want to be
Negative 7.
negative 7. Why? Because I need to have them opposite. So I multiply by negative 7. So I get negative 35x minus 14y equals, what's that, 28? And now I can eliminate my y's. If I eliminate y's, I get negative 29x equals 58. Anybody want to guess how many times 29 goes into 58?
So
That's a terrible guess.
Add the two
Numbers?
equations?
Yep. So what's 58 divided by negative 29? Anybody?
2.
Negative 2. Say x equals negative 2. Now I take that negative 2 and I need to plug it into an equation. Again, I would probably pick the top equation. So I get 3 times negative 2 plus 7y equals 15. Negative 6 plus 7y equals 15. Add 6 to the other side. 7y equals 21. What's y going to equal?
3.
Now what's my answer going to be then?
Negative 2, 3.
Negative 2, 3 as an ordered pair. Again, on your quiz, assignment, stuff like that, make sure you write your answers as an ordered pair. If they don't give you x, y, let's say they give you letters like C and D, put them in alphabetical order then. You should always go alphabetical order. Right? And there's your assignment.